Hi, my name is Aunia Atira binti Robi and I am from IMS560.
Assalamualaikum, my name is Shafika. My number matric is 2025513479.
My name is Umumai Sarahani binti Zulkarnin. My student ID is 2025157919.
My name is Zahida Aisha binti Muhammad Rasidi. My student ID is 2025395581.
Assalamualaikum and a very good morning to everyone. Let me introduce myself first. My name is Aunia Atira binti Robi and I am from D1 CDIM 26240C. Today, I will be presenting about a cap theorem. First, let me explain the introduction. Many modern applications use distributed system, which means the system run on multiple servers instead of just one. This helps improve speed, reliability, and overall performance. However, when data is stored across many servers, several challenges can happen, such as delay, network failures, and inconsistent data. Because of this issue, a computer scientist named Eric Brewer introduced the cap theorem. This theorem helps developers understand the trade-off they must make when designing distributed system. According to cap theorem, no distributed system can be perfectly achieve all important properties at the same time, which is consistency, availability, and partition tolerance. Now, let's look what a cap theorem really means. The theorem states that distributed system can only provide 2 out of 3 guarantees. First, consistency, which means all servers show the same and the most recent data. Second, the availability, meaning the system will always respond to a request even if the data may not be updated. The third is partition tolerance, where the system continues to work even when some server cannot communicate due to network problems. Since the network failure is unavoidable, system designer must choose between either consistency and partition tolerance or availability and partition tolerance, depending on what the system needs the most. And this is the explanation of cap theorem.
Here is a real-life example of the CAP system. As we know, CAP system cannot distribute a system all the CAP in at the same time. So we have to choose either is with C or with P. So the first example is CP system, which is consistency plus partition tolerance. So this system prefers accurate data over fast availability. For example, we have Google Big Table, HBase, MongoDB in CP mode. So, what is a real-life scenario that we can relate with these examples? First is bank transaction system. For example, you have to transfer 500 from account A to B. So, the system must ensure balance changes correctly on all machine. From account A, from 1,000, and then you have to transfer 500 to B. So, when the transfer is successful, so the account B have 500, and the account A must update the new value after we transfer. So if a server is unreachable, it will be blocked the transaction after then with wrong balance. Next is AP system, which is availability plus partition tolerance. This system continue running even if some server cannot communicate. Data may be eventually consistent. For example, we have Amazon Dynamo BN. This database is built for extreme availability, which is shopping carts, product lists, and others. If there's partition, it still lets you read or write. and later data syncs across regions. For the real life scenario, we could say shopping cart in Shopee or TikTok shop. Even if one server is slow, you can still add items to your cart. So this is example of CP system. Next is CA system, which is consistency plus availability. This system only works when there is no network partition. First, for the examples, traditional relationship database, which is on single server, like MySQL, PostgreSQL, and others. This database is always consistent and available for user to use it. Also, there's no partition because there's only one mode. And also, the real life scenario is small business system like POS system running on one local database server.
Implication for system design. CAP theorem tell that in a distributed system, we can achieve all the three of consistency, availability, and partition tolerance at the same time. So system design must prioritize two based on what the system needs most. For example, CA. CA is a prioritized consistency and availability suitable for a single site system. CP prioritizes consistency and partition tolerance suitable where data correctness is critical. And the last one is AP, prioritize availability and partition tolerance suitable for the system that need high uptime. The function of CA system is work well if network partition are rare. The second one is a typically centralized or single-site system. So, such as example, traditional relational database in a single data center. The second one is CP system function. The function is a maintain correctness even if some nodes are unreachable. And the second one is a sacrifice availability temporarily during network partition. So, such as example, hash-based. The second one is MongoDB, and the last one is CP mode. So here, why we cannot have a CAP together? Because they cannot all happen at the same time in a distributed system. During a network partition, if we prioritize consistency, some nodes may not respond. Availability is reduced. If we prioritize availability, we might return outdated data. So consistency is reduced. System design must choose two and compromise on the third.
Lastly, when we build a system like YouTube, the CAP theorem help you decide what to focus on because millions of users are watching YouTube at the same time. So we need to stay available and handle that network issue. This means the system might sometimes show slightly outdated data. So for the conclusion, CAP theorem is a fundamental concept that helps us understand that the limitation and trade-off in distribution system. Next is evidence from journal and article. First, we found an article about evaluate CAP theorem on a stateless 5G core, which is 5G core implement CAP theorem in their system. Next is CAP theorem on blockchain consensus system, which is the same. They implement consistency and availability. The next article is cryptocurrency meets CAP theorem, which is the same. They implement the CAP theorem. Next is deploying access control enforcement for law in the cloud age with the help of CAP theorem. Next is evidence from journal and article. First, we found an article about evaluate CAP theorem on a stateless 5G core, which is 5G core implement CAP theorem in their system. Next is CAP theorem on blockchain consensus system, which is the same. They implement consistency and availability. The next article is cryptocurrency meets CAP theorem, which is the same. They implement the CAP theorem. Next is deploying access control enforcement for law in the cloud age with the help of CAP theorem. Next is Brewer conjecture and the feasibility of consistent, available, and partition-tolerant web service. And lastly, the CAP theorem with Apache, Cassandra, and MongoDB.